Today I'm going to discuss about the most complex topic I think in optics. It's ocular axes and the angles. That all the angles is alpha, kappa, lambda, and axes like fixation target and pupillary axis, line of sight, visual axis, keratometric axis, fixation axis, and many more. They're all pictures is chaos, isn't it? So let's start and let's divide it in a slow manner, okay? So I think it will take time, but let's move. So first of all, trying to talk about some landmarks and points, which is very important, but other points are also important. So sometimes we talk about vertex. Vertex means the corneal intersects at the line of sight. Whenever line of sight intersects with the cornea, we call it as a vertex. Okay. Whenever we call apex, what do we mean by apex? The point of a maximum corneal curvature, we call it apex. Okay. Anterior pole, what do we mean by anterior pole? Most forward corneal point is anterior point. See, sometimes you get confused. We call anterior pole and apex. Apex means maximum corneal curvature. It means curvature. Okay, it is curvature. And anterior pole means the most forward corneal point. It is not necessary if some point of the cornea is most forward means it has to be corneal curvature has to be maximum. No, that's not the case. So that's why the two things are different things. Coaxially sighted corneal reflex, that is vortex normal. Okay, that means the corneal intersection of the video keratoscope axis when the eye is coaxially sighted. Okay, center of rotation of the eye, it is almost not fixed, but yes, we call it fixed pivotal point. Pivotal means the point around which it rotates. Okay, usually around 13.5 mm inside of the eye from cornea, so it is called center of rotation. So this all the terms will come later. Okay, first of all, I want to make clear that there is no true optical axis in case of human eye, because to call optical axis true optical axis, the four surfaces, corneal front surface, corneal back surface, lens anterior surface, lens posterior surface, must have linearly and placed straight optical center. So then after we have optical axis. So in case of eye, there is no true optical axis because all these four surfaces are not straight ahead or are not aligned. So that's why we don't have true optical axis in case of our eye. Okay, so when we try to align it, so it's not always possible to align. Okay, you can see p4 is there and p1 is there, p2 is there, so it's not possible, and one inverted, this one is there, so it's quite impossible to align all four Purkinje images in a straight line. So that's why optical axis in a true nature doesn't exist in our eye. Let's come to the visual axis. What do you mean of visual axis? It's, I think it's most simple axis that we can describe. Visual axis is the line joining the fixation point from fixation point to fovea. But you have to understand, it's not just line joining fixation point to fovea, but it has to pass through nodal point. It's crucial to understand. Okay, it has to pass through a nodal point, otherwise it won't say visual axis. Visual axis is convenient reference axis for visual functions, particularly as it does not depend upon the pupil size. So visual axis doesn't depend upon the pupil size and usually close to the line of sight at the cornea and entrance pupil. So it's close to the line of sight. Visual axis is not actually a practical thing to approach, so we always approach visual axis as a line of sight in practical, because in practical line of sight is um, a replacement of visual axis. Okay, so basically visual axis is theoretical construct, not a practical construct, because the nodal point always changes from one eye to another eye, isn't it? So visual axis from fixation point passes to the foveal point, fovea, but it has to go through so nodal point. That's what visual axis is. Okay, so from this picture also, from fixation point it passes, see, this is visual axis is this, it passes through this and through nodal point and it passes to fovea. Okay, this is the what you call visual axis. So line of sight, the first thing I want to emphasize in line of sight is this clinical counterpart of the visual axis. Visual axis is not used clinically. Clinically used line of sight. What is line of sight? This is a line joining fixation point. it must join fixation point. It pass through the center of the entrance pupil. You know entrance pupil, isn't it? Entrance pupil is image of a pupil made by lens, object space lens, made by cornea, which is lens means cornea. I'm sorry, don't confuse with this lens. If image of the pupil made by this lens, which is image space thing, it will called exit pupil. So entrance pupil is image of a pupil made by cornea, because object space lenses. Okay, which means lenses means cornea. Okay, so line of sight means from fixation point to the entrance pupil, center of the entrance pupil, not just entrance pupil, center of the entrance pupil. The line of sight is the most important axis from the point of view of visual function. From point of view of visual function is most important axis, including refraction procedure. It is defined the center of the beam of light entering to the eye, because entrance pupil means light entering to the eye, isn't it? And this axis shows the center of the beam light is entering to the eye. That's why in visual function the line of sight is very important. And fixed because pupil center may alter with the fluctuation of the pupil size. So line of sight is cannot be fixed. It fluctuates a little bit because pupil center may alter. Pupil center may alter with the fluctuation of pupil size. With pupil size, pupil fluctuation of pupil center also, and with pupil center fluctuation, there is fluctuation of entrance pupil center also. So just understand clinical counterpart of the visual axis is line of sight. Okay, so this is line of sight from fixation to the entrance pupil, and it goes from vertex to entrance pupil. It's central important, not the pupil, center of the pupil. Many of the students write center of the pupil. It's not center of the pupil, center of the entrance pupil. Okay, just understand these things because it's really important whenever you are going to write the answers. Whenever someone says what is line of sight, it's not from, it's a line of sight is a line fixate joining fixation to the end center of the entrance pupil, not the center of the pupil. Okay, so line of sight, this is the line of sight, and this is from fixation point to directly sorry, this is line of sight, sorry, this is line of sight from fixation to center of the entrance pupil. Okay, so pupillary axis, what is pupillary axis then? It is a line passing through the center of the entrance pupil, which is normal to the cornea. Okay, we are not talking about fixation point in case of pupillary axis. Are you getting the point? We don't care about fixation point. What we do care is a center of the entrance pupil and the line that joins the cornea with being normal, being 90-degree. The pupillary axis is used as an objective measure of judge of amount of eccentric fixation and condition in which a retinal point other than center of the fovea is used for the fixation. Wait, see this. In case of pupillary axis, we are not regarding anything as fixation point. From the center of the entrance pupil, the line passes through cornea and by becoming 90-degree with the cornea. That's important, and that's called fixation axis. Fixation axis and optical axis always closer together. Okay, always closer together, and that's why in clinical counterpart, I have already told you there is no fixation axis in eye. So there is no optical axis in eye. Sorry, there is no optical axis in eye because true optical axis is not there in eye. But pupillary axis, we can define it. So that's why clinical counterpart of the optical axis is pupillary axis. Just remember this. Okay, clinical counterpart of the, so same clinical counterpart of the visual axis is line of sight. Clinical counterpart of the optical axis is pupillary axis. Okay, so in this case, see this pupillary axis from center of the entrance pupil, center of the entrance pupil, there is 2 points. One is line of sight, another is pupillary axis, and it passes so that you can see 90-degree made with the cornea. Okay, another point is here with 90-degree made with cornea. We are coming there. Okay, this point is called keratometric axis. So don't worry, I'll talk about it. So fixation axis, so fixation axis means it definitely comes from the fixation point, and then where it goes, that matters. Okay, so this is the line passing through fixation point to center of the rotation of eye. As I have already discussed, center of rotation of eye is usually 13.5 mm behind the cornea. So fixation axis is a reference for measuring eye movement. Oh my goodness, just say one times visual perception book or Adler's physiology book, the movement, eye motion chapter, you will find fixation axis a lot of time. Okay, so from fixation point to center of the rotation, and the angle between optical axis and fixation axis is called, isn't it, gamma? So it's there sometimes. I don't know the gamma is that important or not, I don't know. Okay. Kappa is very important. So from fixation point to center of the rotation, isn't it, center of the rotation, this line is called fixation axis. This line, can you see? Okay, this line is called fixation axis. Okay, keratometric axis. Okay, keratometric is, just remember, is an instrument axis. The keratometric axis intercepts the line of sight. It intercepts the line of sight at the fixation target. So line of sight should be intercepted at the fixation target, isn't it? The keratometric axis intercepts at the cornea at vertex normal. Now another point. Here we see normal. Now here we see normal, isn't it? Let me. Okay. This normal I am talking about, isn't it? This normal, the keratometric. So fixation target crosses the cornea with vertex normal. Okay, another very main important point. See, first thing from fixation point, second it makes vertex normal with the cornea, and again third point, which is the center of the corneal topography map. This position does not coincide with the anterior corneal apex, so it doesn't coincide with the anterior corneal apex. It's really important. And then see, and then first it has to come from fixation point, then it makes 90-degree with the cornea, then it coincides with this point. This point is very important, this is unique point. See, if you make a circle around the cornea, then this point is corneal center of curvature. So there are three things actually. First, target, which is definitely instrument. Second, it makes 90-degree with cornea. And third, it meets to the corneal radius center. If cornea, we make cornea as a circle, then it should meet the corneal center of curvature. It should meet the here, 90-degree here. So it's quite fascinating. Three things you have to understand, and quite complicated too, isn't it? Keratometric axis. So I don't know. I'm being able to explain or not, but I think I'm explaining three things quite clearly. First, it should match with the target, fixated target. Second, it makes 90-degree with the cornea. Third, that it reaches toward the center of the cornea. See, this figure you are not seeing anywhere, do you? This dot line, which means it it they make from anterior cornea, isn't it, a circle, and then this is the center of the circle. So let me show you in this figure. Okay, can you see this? C, CC means center of the curvature of the cornea, and it comes to this 90-degree, and it comes to direct fixation point, isn't it? The sorry, isn't it the keratometric axis? This is keratometric axis. So that's the case. Okay, keratometric axis means this. Okay, finally, let's just see all the things which in one slide. Optical axis connects the center of the curvature of refracting surface approximate by the center of centering Purkinje image there, and we cannot do that. It's absolutely, we cannot do that. It's there, so there is no perfect optical axis, true optical axis. The visual axis, it connects the fixation point to the fovea and passes through the nodal point. It's central, important to understand. Many of the students just tell from fixation point to the fovea. It's not true. You have to mention and dash. Okay, another thing, line of sight. Line of sight is a what counterpart of which, visual axis or optical axis? Definitely visual axis. Clinical counterpart connects the fixation point to the center of the entrance pupil, and the center of the exit pupil clinically matched to the visual axis. So it's clinically matched to the visual axis. It should connect from fixation point to the center of the entrance pupil. Pupillary axis is a counterpoint of optical axis, isn't it? Originate from the center of the entrance pupil and intersects to cornea perpendicularly, clinical match to the optical axis. And in pupillary axis we do not consider, we do not talk about fixation. In both 2 point we do not talk about fixation. Fixation is not necessary. One is pupillary axis, another is optical axis. We don't take consider about fixation point. Okay, so we don't consider fixation point. Fixation axis definitely it connects to the fixation point and to the center of the rotation. Center of the rotation lies where? 13.5 mm behind the cornea. Okay, video keratoscopic sketch connect with the fixation point to the instrument and to the center of the curvature of the cornea, intersecting perpendicularly. So three things I have told you: from fixation point to the center of the cornea with intersection cornea with perpendicular. The three things is matter. Okay, so now I'm going to talk about angles like alpha angle, kappa angle. There are a lot of things, a lot of angles. Let me grossly briefly tell about the angles. When we are talking about lambda, the angle between pupillary axis and the line of sight. Finished. When we are talking about alpha, angle between optical axis and visual axis. Finished. When we are talking about kappa, the angle between pupillary axis and the visual axis. Finished. And when we are talking about gamma, the angle between fixation point and the optical axis. So I think the most important is kappa because we are talking about this kappas in uh, refractive surgery point of view. Kappa is quite important. Okay, so the angle lambda is basically, see, the lambda basically formed between the pupillary axis and the line of sight. Whenever we are talking about angle, we are talking about two straight lines, which is line of sight, and another point where it meets, isn't it? It's apex. So three things make it an certain angle. So that's why angle lambda means two axis and the point apex where they meet. So whenever you heard lambda, it's about pupillary axis and the line of sight, and the apex is at centered at the pupil. Pupil means center of the entrance pupil, isn't it? So this is pupillary axis. See, this is pupillary axis, and another is line of sight, isn't it? This is line of sight. This is line of sight, and it matches there. Okay. Another is angle kappa, formed between the pupillary axis and the visual axis. Well, this is pupillary axis, and what is this? This is visual axis. So this is the angle kappa. Okay, this is angle kappa. So line of sight. See, you can understand these things. Okay, I'll later on. Line of sight means here and here. This is lambda, isn't it? So you make another line here, and here is line of what do you call pupillary axis, and here line pupillary axis. This is called angle kappa. Okay, and again angle alpha formed between optical axis and visual axis. This is optical axis, and again where is the visual axis? Visual axis is this is the visual axis, and its apex at the nodal point, and its clinical counterpart of the angle lambda. Okay, it's a clinical counterpart. Okay, angle lambda or angle gamma. What is the angle gamma? So angle gamma is formed between the fixation axis and the optical axis, and its apex at the eye center of rotation here, isn't it? Optical axis and the fixation axis. This is angle gamma, this long angle gamma. Okay, so these are the angles. So I have already talked about the angle alpha and gamma. So only one thing that I am curious and I am willing to talk is the angle kappa. See, first I will again emphasize the angle kappa. Angle kappa is formed between the pupillary axis and the visual axis. Okay, so let's think pupillary axis is very straightforward. So its pupillary axis means very, sorry, very straightforward. Okay, let's take an example. This is pupillary axis. Okay, pupillary axis from entrance pupil to a normal with the cornea. And you know that if phobia actually in myopic are if axial length are longer, in hyperopic axial length is shorter. That's why whenever we are talking about angle kappa in case of, especially in case of refractive surgery. Angle kappa in case of hyperopia, see, in case of hyperopia, when axial length shorter, it's always larger in shorter axial length. But in case of longer axial length, what we have talked already, in case of longer axial length, for this case, see, for this is smaller angle kappa. That's why in case of hyperopia, axial hyperopia, angle kappa is larger, and in case of myopia, axial myopia, angle kappa is smaller. That's why it's there may be a problem with, without doing calculating angle kappa refractive surgery, there is a chance of decentering the optical zone, ablation zone. So it's central important why we're doing these things. So in recap, optical axis, all four frequency images must align. It is not practically possible. There are no true optical axis in our eyes. Visual axis is from fixation point to fovea, but must pass through nodal points. And another point is this, what is this? This is fixation line of sight. Line of sight means from center of the entrance pupil making 90-degree with cornea. Okay, its clinical counterpart, sorry, no, from fixation point to the entrance center pupil, I'm sorry, this is not 90 point, this is clinical counterpoint of visual axis. Pupillary axis is definitely clinical counterpoint of optical axis, from the center of the entrance pupil making 90-degree to cornea, that line. And these two lines from optical axis and pupillary axis, we don't talk about fixation point. And fixation axis from fixation point to the center of rotation, which is approximately 13.5 mm behind that. Video keratoscopic axis, that's quite funny, from fixation to center of the corneal curvature making 90-degree. And obviously we know that from any circle radius makes 90-degree, so it making 90-degree, we don't have to talk about it, because it naturally making 90-degree, it will make 90-degree. That's the law of physics or mathematics, isn't it? So, in conclusion, these are the angles and the axes. So, it's very important whenever you become a scientist or you work in ophthalmic industry for making lenses and all these things. But in clinical point of view, in refractive surgery, as an optometric point of view, it's quite important. I think it's quite difficult topic and quite you forgot a lot. But I hope you understand few things from this axis and all these things. So this is the great book. I have taken two reference only. From these two books I have done a lot. This is book from my favorite author, Professor Dr. Josh Esimelis, and this is the great book that I have always read this book back and back again. Optics of Human Eye, when I was a student, when I was doing masters, and when I am a faculty. So I think that's it. This big two book, and they are great resources for the exercises. And Bistan choose.